Filme, o instinto selvagem que invade a sensação de perigo nos define. Sinto um frio na barriga, tudo isso me lembra a cena de um filme. O instinto selvagem que invade a sensação de perigo nos define. Celeste divino merece hino, seu corpo
Good day to you all. Francis Xavier, Department of Management Studies, FXDoMS, along with Francis Xavier Alumni Association, proudly organizes the alumni webinar interaction on the topic Industry 4.0 and Overview. I feel glad to introduce our prominent alumnus, Mr.A.Karthic. He serves as the business administrator at Systems LLP, based out of Bangalore, which focuses on providing Industry 4.0 solutions. He is always keen to learn new things and ponders for ways to bridge the gap between technology and management. Finally, his thoughts are becoming a reality with Mindset Systems, giving shape to his dreams. He is currently working on how Industry 4.0 helps in quality management, predictive maintenance, efficiency, and overall productivity. He is an avid music lover and is interested in digitization technology and automation of music. Over to Mr. Karthik.
Thank you for the introduction. Hello everyone, I'm Karthik. It's a pleasure to connect with you all. It feels great to associate with Francis Xavier Engineering College, and I'm happy that the college is utilizing this situation, the COVID situation, as an opportunity for the benefit of the students so that they know and learn about practical industry scenario through online platforms. And I feel honored to be one of the speakers in the series. So today's agenda, as some of you must have already seen in the flyer that was sent out, this is what we're going to be covering. Industry 4.0, what it is, what are the areas of implementation, what industries need. It's a word and people are wondering what really needs to be done. Where can they start? How it benefits the industries and the end users? What are the challenges? Okay, so before we move on, we need to know what is revolution and what is industrial revolution. So what is revolution? It's a dramatic and wide-reaching change or shift in conditions, attitudes, and operations. A dramatic and wide-reaching change or shift in conditions, attitudes, and operations. What is industrial revolution? It's simply wide-reaching change due to development of new technologies and approaches. Okay, so just a little bit of history so that you know how Industry 4.0, 3.0, 2.0 and 1.0 has been progressively working through in the world. So let's talk about Industry 1.0. The late 18th century introduced mechanical production facilities to the world. Water and steam powered machines were developed to help workers in mass production of goods. The first weaving loom was introduced in 1784. Okay, so however, there was a limitation, and the limitation was that they couldn't achieve the scale. Okay, they couldn't meet the demands. So this problem was addressed in Industry 2.0. Now what is Industry 2.0? So the beginning of the 20th century marked the start of the second industrial revolution. The main contributor to this revolution was the development of machines running on electrical energy. So electrical energy was already being used as a primary source of power. Electrical machines were, as you know, more efficient to operate and maintain, both in terms of cost and effort, unlike the water and steam based machines, which were comparatively inefficient and resource hungry. The first assembly line was also built during this era. You may be aware of a car model called Model T by Ford. You can search online. It's Model T by Ford. Which was the first assembly line in the world. This further streamlined the process of mass production. So the mass production of goods using assembly line became a standard practice in Industry 2.0. This era also saw the evolution of the industry culture introduced in Industry 1.0 into management program to enhance the efficiency of manufacturing facilities. Various production management techniques such as division of labor, just-in-time manufacturing, and lean manufacturing principles. These all things were introduced to improve the quality and output. So though this era was standardized, there were challenges, there were difficulties, certain works which were tedious or we can say unsafe, unpleasant, uh, or exhaustive for human co-workers. These works decreased efficiency and productivity. So to overcome this, they had introduced Industry 3.0. So the next industrial revolution, that is Industry 3.0, was brought about and spurred by the advances in the electronics industry in the last few decades of the 20th century. So the invention and manufacturing of a variety electronic devices and software systems resulted in reduced effort, increased speed, greater accuracy, and even complete replacement of human agent in some cases. Programmable logic controller, or PLC as we call it, which was first built in 1960s, was one of the landmark inventions that signified automation using electronics. Apart from controlling the hardware, the software systems also enabled many management processes such as enterprise resource planning, ERP, then inventory management, shipping logistics, product flow scheduling and tracking throughout the factory. So though there is automation, it still needs input from a human controller. Okay, so the process is automated based on a human input, not by data. Again, this is highly standardized. So I would like to mention that in India, we are in Industry 3.0. We haven't moved to 4.0 yet. There are a few companies like Tata Steel, Bosch, which have already understood it. Most companies in India have just started automating their production. So coming to Industry 4.0. Industry 4.0 is a jargon that was introduced in 2011 in Germany actually to boost the German economy. So Industry 4.0 refers to a new phase in the industrial revolution that focuses heavily on interconnectivity, automation, machine learning and real-time data. This is implemented with the help of something called cyber physical systems, where the manufacturing is more data driven rather than human inputs. So machines communicating with machines. In Industry 3.0, the case was human input was required for machines to perform a certain task. In Industry 4.0, machines communicate with each other. So what's special about these machines can monitor, detect and predict faults to suggest preventive measures and remedial action. So machines are communicating with machines, like I said, there is very less human interference, and also if there are certain deviations or variants, the machine has the ability to take decisions. Also, this focuses on mass customization. So Industry 3.0 was mass standardization. It was highly standardized. This is mass customization. So QCDMS and time to market goals are achieved. So what is QCDMS? Quality, cost, delivery, morale and safety. Why is there so much of noise for the past 5 years is because now we have technologies available and it's easy and economical to start using such solutions. Okay, so from Industry 1.0 to 3.0, you can see on the screen the product development approach. Industry 1.0 to 3.0 is craft to automation. So there are certain skills which are automated till 3.0. Now in industry 4.0 what is happening is machines have skills. So automation along with skills to take decisions wherever necessary. Before we step into cyber physical systems, let's understand what are the design principles of Industry 4.0. So there are four design principles. The first one is interconnection. That is the ability of machines, devices, sensors and people to connect and communicate with each other. Okay. Information transparency, that is vast amounts of useful transparent data that helps in identifying key areas that can benefit from innovation and improvement. I'll definitely explain in further slides. Just understand what are the four design principles, and in case you have queries I'll definitely share my email so that your queries are answered. So the first one is interconnection, that is communication between machines and people. Information transparency, that is transparent useful data that helps in identifying key areas that can benefit from innovation and improvement. The third one is technical assistance, solving urgent problems on short notice. Also, conducting tasks that are unpleasant, exhaustive and unsafe for human co-workers. Okay. And then the fourth one is decentralized decision. That is the ability to perform the task as autonomously as possible. That means without human interference. Okay. Human interference is required only in event of conflicts with the intended goals. Okay. So I hope you remember all the four design principles: interconnection, information transparency, technical assistance and decentralized decision. Now let us have a look at the components of Industry 4.0. IoT, as you can see on the screen, Internet of Things, big data, simulation, artificial intelligence, machine learning, cloud. These are all certain components of Industry 4.0. Now all these are possible with the help of something called cyber physical systems. Now let us see what are cyber physical systems. To understand this term, let's split the term into three. One is cyber, physical and then system. Cyber means related to computer or virtual reality. Physical means things perceived through senses or environment around us. System is a set of things working together. So there is a strong component of cyber world and there is a physical world. The physical world here means the physical space or the space in which the system is operating. So cyber world and then physical world or physical space, and then there is an interaction between them. Let me give you a simple example. You must have heard of Tesla cars, automated cars with certain features like autopilot, collision avoidance, etc. So how are these cars able to maneuver safely without human interference? It's done with the help of sensors. So here the car is a system operating in a physical world. The sensors in the car sense the obstacles, the speed, the lane and everything around the car and the technical controls. Okay, everything is being monitored by sensors. Now for example, let us assume the car is moving and in a few meters a truck in front of the car is idle and the adjacent lanes are also busy. The sensor senses the obstacle, that is the truck here. This data is sent to the cyberspace. So from the physical space, the sensor senses that there is an obstacle. This data is sent to the cyberspace where computation is performed based on certain rules, etc. and decisions are taken. In this case, a decision has to be taken to stop the car safely without colliding. So from the cyberspace, the decision is activated or communicated to the car with the help of something called actuators. Okay, so there is two-way interaction. interaction with cyberspace due to change in physical world, interaction in physical world due to change in cyberspace. Okay, so conceptually we can say cyber physical systems or CPS is embedded system, that is embedded system plus physical system. Okay, embedded system that interacts with the physical world. So what is an embedded system? In simplified terms, we have some kind of a software working on some kind of hardware. We say that the software is embedded in the hardware. So now we have a loop. The loop is sensing, computation, and control. Sensing the physical world, sending the sensed information to the cyberspace for computation and decision making. Then that decision is activated with the help of actuators to control the physical space, and this goes on. So this is an example where a production facility or a manufacturing facility is implemented with cyber physical systems, and all the data and all the departments, everything is interlinked. So areas of implementation. What are the areas where Industry 4.0 can be implemented with the help of cyber physical systems? So I have mentioned a few. Smart manufacturing, artificial intelligence, twin model. This is very important. This is the next big thing. Twin model for components and machines, performance monitoring, diagnostics and decision making, and self-optimization. In healthcare, you must have heard of robotic surgery or image guided surgery, and then we have high accuracy fluid flow control. Then in transportation, we have real-time monitoring of traffic infrastructure, transit priority, vehicle health monitoring, proximity detection. So here you can see a robot performing a surgery on its own without human interference. Okay, and then we have autonomous cars where the car is detecting the other vehicles or things around and also the obstacles. So then we have in automotive and AV collision avoidance system, parts performance. So sensors can monitor how the parts of the car are performing, efficiency, security, predictive maintenance. So this is also an important term. I'll explain how this is done. And then autopilot. Okay. So what are the challenges in implementation of Industry 4.0? So the main challenge is economic, high economic costs, excessive investments, and resistance to model adaptation. So to change from 3.0 or 2.0 to 4.0, excessive investments are required. Then we have political and legal challenges. That is lack of regulations, standards, and forms of certifications. So we are yet to develop regulations and standards for Industry 4.0, and we have unclear legal issues. Okay. Then we have social. So as you know, if most of the things are automated, there may be a situation where people may lose jobs. So loss of many jobs due to automation and reluctance to change. Okay. Then organizational or internal. That is reliability and stability needed for critical machine to machine communication. Okay. We need a reliable, high confident and stable system for machine to machine communication. Otherwise things can go wrong. Okay. Then lack of adequate skill set. These are all the challenges we may face before, during, and after implementation of Industry 4.0. So this is the next big thing, digital twins, through which certain challenges are overcome. In simplified terms, if I have to explain you what is digital twin, it is just a virtual copy, a digital replica of a physical asset. You see in the picture, there is a windmill which is a real asset performing in the real world, and then there is a digital replica of the asset on the right. Okay, see the picture please. There is a real physical asset working on a real world, and then we have a digital replica of the same asset. Not only the aesthetics, I'm not talking about the design alone, it also shows how the asset is performing. For example, the efficiency, the wear and tear of parts, etc. Everything is monitored about the asset which is in the real world in the digital replica. So digital twins connect the real world and the virtual world by collecting real-time data from the installed sensors in the asset performing in the real world. So the sensors collect data to represent real-time information about physical asset. This data captured is then simulated in virtual copy of the assets, that is computerized version of a physical asset. So after receiving the information from simulation, the parameters are applied to the real asset to optimize the performance. So I told you I'll explain what is predictive maintenance. In simple terms, what if we could spot problems before they happen? So in a machine, we can implement sensors which can collect the data of the aesthetics, efficiency, performance of the parts, detect if there are faults, and once sufficient data is gathered, we can extrapolate and predict the trend of performance of several parts of the machine. Okay, I have shown you a graph, a simple graph. So if you look at the graph, we have measured data with the help of sensors. The blue part shows the measured performance of the machine, the trend of which is extrapolated so that we almost surely know that the machine is going to fail in the next 9.5 days. So RUL is remaining useful life. The machine has a remaining useful life of 9.5 days. Preventive measures are taken before failure, and therefore the maintenance cost is reduced and also the downtime, which leads to increased productivity. So this will be helpful for technical as well as management students. The usual product development process and product development process using digital twin. What is the difference and how does it benefit the manufacturers and end users? So what happens in usual product development processes? You have an idea to create and manufacture a product for the market. The idea in your mind has to be converted to design. That is called concept design. Usually there are 3 concept designs for an idea. These designs are developed using computer aided designing softwares. Then a prototype is constructed and sent for testing. Okay. Now based on the results of performance in testing, if the product is not satisfactory, necessary changes have to be made in the design and then required to be done unless and until the quality and performance of the product is as expected or as per required standards. Okay. Once we achieve satisfactory results in testing, it is sent for manufacturing, and then from manufacturing to the market, and then it reaches the end user. So once it reaches the end user, it has nothing to do with the concept development or prototype construction again. So this testing time has to be reduced, right? I'll give you an example of a car again. Hindustan Motor Ambassador. It takes around 3 to 6 months to test ambassadors. This is true. You can Google and search about testing of ambassadors. It takes around 3 to 6 months. So the time to market is very high. And this testing time is reduced using digital twin or simulation. Now let us see how this time for testing is reduced. What happens in case of product development process using digital twin? You have an idea to create a product, manufacture a product for a market. You convert the idea in your mind into a design, a concept design. Then you develop that concept design. Okay. Then the replica is simulated using digital twin. Okay. On a computer, the real asset is simulated using twin technology. So what happens is the testing in real world is simulated in a computer, so it becomes faster. You can actually know, I actually told you what is predictive maintenance, right? So you can predict what is going to happen in future, how many days the machine is going to run, or what is the condition of the machine, etc. So the same thing is done here. Simulation actually shows how the machine is performing and what will be the condition in future. Okay, so simulation using digital twin makes the testing faster. The time consumed for testing is very less. Okay, the testing process is very fast, so the time to market gets reduced. So you have a car, and with the help of sensors you already know that this particular part of the car is going to fail in the next 10 days. That is what I explained you, what is predictive maintenance, right? So the after sales team is alerted with the help of sensors. This user's car has this particular fault and it's going to fail in the next 10 days. So they are already ready with the spares. It minimizes downtime, improves profit, the customer service and satisfaction is also improved. So now yours is not the only car in the market. There are hundreds of cars, similar cars that you are using. For example, a particular model of BMW that you are using, it's available with many other people. Now, with the help of sensors, these manufacturing departments like design departments, right? Then after sales, all of them gather the data of why the product or the particular part is failing, which part is performing very well. All the details are available with the design team and the after sales team. Okay, so they already know that this issue is there in many other cars, so they can improve that particular design for that car, right? So if you see in the picture, the feedback from the after sales goes to the design team, so they will see what actually is the problem in the design and then rectify it and make necessary improvements and innovations in the design so that the parts perform as per required standards. Usual product development process is unidirectional. That is, from idea generation to the end user, it is unidirectional. But in case of product development process using digital twin, it is two-way. So once it is with the end user, everything is monitored, right? The how the car or whatever the particular product is performing, everything is monitored through sensors, and that data is sent to the concept design team, and they make the necessary changes, improvements and innovations so that they can improve their product. So what happens? Why should they improve the product? So in those days and even now, in some cases, the quality of the products were very high. The products were highly reliable. They were built to last. For example, again, ambassadors, they are still rolling on the roads because we did not have regulations. But today things are not the same. We have regulations. The car you buy today is fit for use for the next 15 years only, right? So now how digital twins help manufacturer build products that are good in quality as well as they meet the required standards and regulations. So just draw 5 squares, okay, near to each other, just 5 squares. Now let us assume that these 5 boxes or squares are components of the engine air filter of a car whose design lifespan is 3 years. Name the boxes 1 year, 2 year, 3 year, 4 year and 5 year. Okay, just 1Y, 2Y, 3Y, 4Y and 5Y for your understanding. So we have come to know with the help of simulation that the component 1Y is lasting for only 1 year. So the quality of component 1 and 2 has to be improved so that it does not wear before the end of design lifespan, that is 3 years. It has to last for 3 years. So the quality has to be improved. Now if you look at component 3, the quality of component 3 is as per the designed lifespan, that is 3 years. So no changes need to be done to component number 3. Coming to component 4 and 5, which lasts for 4 years and 5 years, this is where the quality has to be reduced. So through simulation we have come to know that the quality is very good and it is lasting for more than 3 years, right? So we have to reduce the quality of these two components, that is 4Y and 5Y, to the extent that it lasts only for 3 years. It lasts only for 3 years, not 4 years or 5 years. So through simulation, we can know where we need to improve the quality and where we need to reduce the quality as well. So the customers are not losing anything here. The product is made as per the design lifespan. For example, if the design lifespan is 3 years, the product is made to last for 3 years. So the quality is under control. And the manufacturers are also making the product so that it lasts for only 3 years, not more than that. Okay, so this gives manufacturer improved profits on a sustaining basis. So with the help of digital twin simulation, we can know where the improvements in the designs are required, where the innovations are required, and then it reduces testing time, then it improves reliability of a product, the production becomes faster, and hence the time to market gets reduced. So predictive maintenance helps in minimizing the downtime, which improves customer service and satisfaction, reduced cost of production and maintenance. All this indirectly helps in improving profits on a sustainable basis. So at Mindset Systems, we are Industry 4.0 solution providers with more than 10 years of experience in the field. Having expertise in CPS and digital twin, we also develop cyber physical products and simulation systems for the clients. So I am working on how Industry 4.0 helps in quality management, predictive maintenance, efficiency, and overall productivity. In future, technology and management will blend. There will be techno management, techno marketing. So you cannot take management out of technology or technology out of management. So this was the overview about Industry 4.0, just to give you an idea about what is happening in the industry. Mere watching of this video will not suffice. If you are really interested, you will have to learn and make use of the internet. Especially this time is a very good opportunity for you to learn whatever interests you, not particularly Industry 4.0. And I hope you got clarity about Industry 4.0 and enjoyed the overview. In case you have any queries or you need guidance, I'm sharing my email and number. Please feel free to write to me. I'll share more on topics similar to these which will be useful to you. And please take necessary precautions and protect yourself from COVID-19. Stay home, stay safe. Thank you so much. See you until next time.
Thank you, Mr. Karthic. As you well said, technology and management cannot be separated, which is blended. Thank you for the overview on Industry 4.0. Thank you.
Tell me pretty lies.